What if the solution to modern problems was invented 700 years ago? No electricity, no internet, no refrigeration. Yet medieval people created cooling systems, heating technology, and power generation that worked flawlessly for centuries. Some of their inventions were actually more efficient than what we use today. After Rome fell, many brilliant innovations were lost. But during the Middle Ages, new technologies emerged, perfectly adapted to local conditions, built to last generations, and requiring almost no maintenance. Today, we're exploring 12 of these forgotten technologies. Each one could transform how you think about self-sufficiency. Water has always been essential, but how do you move it without electric pumps? Medieval engineers found the answer in water itself. The water wheel was the engine of the Middle Ages. Picture a stream flowing peacefully through a village. Beside it stands a wooden wheel, 3 meters high, crafted entirely from oak. This single wheel powers mills, saws, hammers, and textile machines. One stream could energize an entire community. The engineering is beautifully simple. Flowing water strikes the wheel's blades, creating rotation. Gears and shafts transfer this movement to various tools. The overshot design, where water flows from above, achieved over 70% efficiency, surpassing some modern turbines. These wheels were remarkably versatile. In the Netherlands, they pumped water from flooded land. In mountains, they lifted groundwater to higher elevations, all without gasoline or electricity. The Noria, a vertical wheel equipped with pots or buckets, continuously drew water from rivers and wells. Originating in the Orient, this technology spread throughout Europe. The mechanism is elegant. The wheel rotates with the current, containers fill at the bottom, then empty into channels at the top. Even more ingenious was the Archimedes screw. This spiral mechanism inside an inclined pipe transported water upward when rotated. Windmills powered these screws, draining entire regions. Without this technology, much of Holland would still be underwater. While Romans built with stone and lead, medieval engineers experimented with wood and fired clay. Hollowed oak and elm trunks became pipes, reinforced with iron rings and sealed with pitch or resin. These wooden pipes lasted decades and cost far less than metal alternatives. Fired clay pipes proved even more durable. Kilned at extreme temperatures, they became rock-hard, withstanding frost and root pressure better than many modern plastic pipes. German cities like Augsburg and Nuremberg supplied thousands with fresh drinking water through these systems. Why were these more reliable than modern pumps? Simple, no moving parts to fail. A water wheel runs as long as water flows. No electronics, no filters, no overheating motors. Micro-hydropower is experiencing a renaissance. Small water wheels, just 1 meter in diameter, can generate enough electricity for an entire homestead. All you need is consistent flow and basic construction skills. The technology remains identical to 800 years ago, only materials have improved. A homemade water wheel costs a fraction of solar systems and runs continuously. No batteries, no inverters, just pure mechanical energy. For anyone living near streams or rivers, this represents the perfect self-sufficient solution. While water wheels powered villages, other technologies provided warmth through cold months. The tiled stove dominated medieval heating. Imagine a stove that doesn't just heat, but stores warmth for hours, releasing it gradually and evenly. These structures consisted of special clay tiles set into lattices of clay and stone. The secret was mass. Stoves often weighed over a ton, storing heat like giant batteries. Once properly heated, they radiated warmth for 12 to 24 hours. You'd add wood just twice daily, maintaining cozy temperatures throughout. Tiles fired above 1,000 degrees and glazed not only looked beautiful, but optimized heat emission. Efficiency exceeded 80%, while open fireplaces managed barely 20%. Even more impressive were hypocaust systems, a Roman legacy further developed during medieval times. This underfloor heating worked without pumps or pipes. Hot air circulated beneath floors through brick channels. A central furnace, typically in the kitchen or basement, produced hot gases that flowed through floor cavities and rose through wall channels. Heat distributed evenly throughout buildings without hauling wood to individual rooms. Monasteries and castles used this to heat vast halls efficiently. Medieval builders showed true genius in cooling technology. Ice cellars were far more than holes in the ground. These underground chambers were strategically positioned, usually on north-facing slopes or beneath thick stone walls. In winter, ice was cut and layered with straw or sawdust. Construction details were crucial. Stone walls, often a meter thick, insulated against external heat. Double doors with airlocks prevented warm air entry. Drainage systems channeled meltwater without damaging insulation. Ice remained frozen until autumn. Earth cooling chambers operated on similar principles. At 2 meters depth, temperatures hold constant between 8 and 12 degrees Celsius year-round, perfect for storing meat, dairy, and vegetables. These natural refrigerators required no energy and preserved food for weeks. These systems cleverly combined heating with cooking. Rather than venting directly outside, smoke traveled through channels and chambers, transferring heat throughout dwellings. Simultaneously, it smoked meat and fish hung in special areas. These systems were remarkably efficient, using a fraction of fuel consumed by modern heating. These techniques are being rediscovered today. Modern tiled stoves blend traditional construction with optimized combustion. Earth cooling chambers offer natural alternatives to electric refrigerators. For energy-independent homes, these represent proven solutions. No electricity bills, minimal maintenance, just intelligent physics and time-tested craftsmanship. When you buy bread today, you don't consider how grain was ground. But imagine crushing every grain by hand. Medieval millers had a superior solution, the windmill. These tower-like structures shaped European landscapes. Typical windmills stood 20 meters high, with 25-meter wingspans. Their genius lay in harnessing energy that was always available and completely free. The technology was sophisticated. For large canvas sails caught wind, transferring power through wooden gears to massive millstones. The upper runner stone rotated above a stationary base. Grain poured between these stones emerged as fine flour. Windmills did far more than grind grain. They pumped water from flooded areas, pressed oil from seeds, even sawed wood. Thousands stood across Holland, making the land habitable. Without them, much of the Netherlands would still be sea. The key was adaptability. Millers adjusted sails based on wind strength, reefing them in storms, extending fully in light winds. The entire mill cap rotated to optimize wind capture. This fine-tuning required years of experience. Screw presses demonstrated medieval understanding of mechanical advantage, multiplying human force 100-fold. By hand, you might exert 10 kilograms of pressure. A screw press delivered a ton. Crushed walnuts in linen sacks yielded golden oil. Wine grapes released pure, clear juice, cleaner than traditional treading methods. Meat preservation was survival itself, especially in winter. Smokehouses combined heat, smoke, and time perfectly. These brick chambers featured basement fireplaces and multiple floors with hanging hooks. Wood selection was critical. Beech, oak, and fruit woods provided flavor while delivering antimicrobial compounds. Smoke slowly dried meat while forming protective bacterial barriers. Properly smoked meat remained edible for months. Salt curing complemented smoking. Meat pickled in brine or rubbed with salt mixtures had water drawn out, creating hostile environments for harmful microorganisms. Combined with juniper or caraway, this produced delicacies still appreciated today. Controlled fermentation represented preservation's highest achievement. Sauerkraut, pickled cucumbers, and fermented dairy resulted from lactic acid bacteria converting sugars to acid, naturally preserving food. These techniques work perfectly today. Small windmills can grind grain for families. Garden smokehouses are entirely feasible. Fermentation requires only jars and patience. For self-sufficient living, these form the foundation of independent food production. Medieval craftsmen created tools without machines or electricity, yet achieved precision that rivals modern manufacturing. This mechanical marvel demonstrates pure physics. A heavy stone disc mounted on a vertical axis stores kinetic energy. One powerful kick sets it spinning evenly for minutes, leaving both hands free for shaping perfectly symmetrical vessels. The secret, weight and bearings. Flywheels often exceeded 100 kilograms of dense stone. Axles ran in wooden or stone bearings lubricated with animal fat. Once spinning, the system's smoothness allowed wafer-thin vessel creation. Medieval kilns reached over 1,000 degrees without gas or electricity. These dome-shaped structures of fireproof brick maximized the chimney effect. Wood burned in separate combustion chambers. Hot gases flowed around pottery before rising through chimneys. Thick walls stored heat, releasing it evenly. Multiple flues optimally directed flames. Experienced potters read temperatures from flame colors, knowing precisely when firing was complete. These leather-covered constructions functioned like giant lungs, generating extreme metalworking temperatures. Two chambers alternated, while one filled with air, the other forced air into the forge. Leather flap valves prevented backflow. Steady air streams heated charcoal beyond 1,500 degrees, making iron buttersoft and perfectly shapeable. Two workers alternating maintained constant heat. Looms transformed raw fibers into complex fabrics. Wooden frames held warped threads, taut while weavers passed weft threads through with shuttles. Different shafts lifted alternating warp threads, creating intricate patterns. Spinning wheels twisted fibers into even threads 10 times faster than hand spinning. Flywheels stored energy, while clever gear ratios spun spindles at high speed. Sawmills combined water power with precise cutting. Water wheels drove crankshafts through gears, moving heavy saw blades vertically. Logs pushed slowly against blades produced even boards, precision impossible with hand saws. Why did these tools outlast modern machines? Pure simplicity. No corroding electronics, no motors with hundreds of moving parts, just robust mechanics from wood, stone, and iron. Well-built looms functioned for centuries. Potter's wheels passed through generations. These tools were genuinely built to last. Imagine sailing hundreds of kilometers offshore. No GPS, no digital compass, just stars. Medieval sailors mastered this with instruments that work perfectly today. This was navigation's ultimate multi-tool. The bronze or brass circular disc determined latitude, told time, calculated prayer times, and made astrological predictions. The genius was precision. Experienced navigators achieved accuracy within a few kilometers through star observation alone. Usage was elegantly simple. Hold the astrolabe vertically, aim at a known star, and the movable pointer on the engraved scale reveals geographical latitude. Combined with star charts, sailors always knew their position, day or night, in any weather, provided the sky was visible. Arab scholars perfected astrolabes in the 9th century. Reaching Europe via Spain, they revolutionized seafaring. Columbus navigated to America with an astrolabe. Vasco da Gama circumnavigated Africa using one. These palm-sized instruments enabled world discovery. No batteries to drain, no mechanics to break, just shadows moving with mathematical precision. Medieval clockmakers engraved complex scales in stone and bronze, showing not just hours, but seasons and moon phases. Manufacturing required astronomical knowledge. Each sundial needed location-specific calculations. Shadow stick angles depended on latitude. Hour divisions varied by season. Masterful sundials showed time within 5 minutes, sometimes more precisely in perfect conditions. Portable sundials fit in pockets. Foldable ivory or wooden models were status symbols for wealthy merchants, working anywhere provided you knew the latitude and had sunshine. Arriving from China in the 12th century, this changed everything. A magnetized needle floating on cork always pointed north, enabling navigation even under cloudy skies. Medieval compass makers developed sophisticated cases. Needles floated in oil-filled bowls, protecting against vibrations. Wind roses with 32 directions enabled precise course determination. Experienced captains even compensated for magnetic declination, the difference between magnetic and geographic north poles. Star charts were medieval road maps. These parchment celestial maps showed star positions throughout the year. Navigators memorized stellar movements, determining position without instruments. Quadrants simplified astrolabes, a quarter circle with degree markings and an attached plumb line. Sailors measured star heights above horizons, calculating positions. Easier to build and use than astrolabes, yet nearly as accurate. These navigation techniques are experiencing revival. Sailors relearn astronomical navigation as GPS backup. Scouts navigate with compass and map. Survival experts build stick and stone sundials. Why does this matter? Technology fails. Satellites shut down. Batteries drain. Electronics break. But stars always shine. Magnetic compasses work without electricity. These medieval techniques are life insurance when modern navigation fails. These 12 technologies share something remarkable. They've worked reliably for centuries without electricity, complicated maintenance, or expensive parts. While smartphones become obsolete within 3 years, medieval water wheels still turn. This transcends nostalgia, it's practical wisdom. Our ancestors built for generations, not planned obsolescence. They used local materials and natural energy sources. They developed self-maintaining systems or made them simple enough for anyone to understand. For them, sustainability wasn't marketing, it was a survival necessity. Resources were precious. Waste was fatal. So they created technologies working in harmony with nature rather than against it. Which technique resonates with you? A small water wheel for your stream? A smokehouse for your garden? Perhaps a sundial for your terrace? The old ways aren't obsolete. They're proven.